Hi guys, this is module 7.1, interior and exterior angles. So, our essential question is what can you say about the interior and exterior angles of a triangle and other polygons? So, we've already looked at triangles and we have found that the sum of all the interior angles of a triangle add up to 180. Okay. Now, the sum of n-gons, which are just representation of more than three-sided polygons. Okay, poly means many. N represents the idea of how many sides. Okay, that polygon has, and basically we use the formula n minus two, so the number of sides. Okay, minus 2 times 180 degrees. And that'll tell you exactly how many or what degrees total you have for interior angles. Okay, and then we're going to look at exterior angles towards the end. All right, so exploring interior angles. So what I want you to do is I actually want you to tear out this triangle. I want you to tear it up. Okay, I want you to this triangle right here. Okay, I want you to tear out the corners. Okay, like thus. I mean, it doesn't have to be perfectly torn just like that, but I just want you to tear off those three angles, those interior angles. Then I want you to try to line them up on one side. Okay, and you're going to realize something about these three angles and what they add up to in a sense of degrees. So the interior angle is an angle formed by two sides of a polygon with a common vertex. So these are interior angles. They're blocked by two sides. Okay, they have two sides right next to them. The vertex is literally right here, here, and here. Okay, so I'm serious. I want you to tear off the corners of this actual cutout piece that I give you guys. Okay, now your turn. um, what theorem is this related to? So if you look at your torn pieces, go ahead and glue them in, by the way, to your notebook. Um, we have a angle 1, angle 2, angle 3, and what do they add up to? Okay, and what theorem is this about? Remember, these angles involve a triangle, right? In this example, so what theorem is this relating to? And we're talking about interior angles adding up to some degree. What degree is it? Okay, it does involve this picture right here. Okay, so that's a part of your question. What theorem is this, and what is that angle? What is that degree? Okay. All right, so we have the triangle sum theorem, which basically says angle 1 plus angle 2 plus angle 3 have to add up to 180 degrees, and that works for all the triangles. So we're going to go ahead and do the whole fill in the blank to complete the proof for the triangle sum theorem. Notice how they do give us line L, okay, that intersects point B. Okay, that's something to acknowledge. And then we're basically proving that angle 1 plus angle 2 plus angle 3 is 180, just like how I said earlier. Okay, that's the theorem itself. Now it says draw a line through point B parallel to AC. This is the parallel postulate. So basically line L is going to be parallel to line AC. Okay, that's what those little arrows mean. Now, so if we think that way, angle 1 is going to be equal to angle something. So let's see. Angle 1's right here. I see with my little eye alternate interior angles. That is angle 4. And the measure for angle 3, let me see. 3 is right here. Okay, so 1 and 4 are the same because of alternate interior angles. And angle 3 should be congruent to angle, looks like 5. Because of the same reason, alternate interior angles. So those two measures are congruent, and that again is alternate interior angles. Okay, so let's see. Now they're saying, well, angle 4 plus angle 2 plus angle 5 are the measures of angle 4, 2, and 5 add up to 180. And that's the angle addition postulate and the definition of a straight line, because 4 plus 2 plus 5, well, that makes up the line that you drew, line L. Okay, so yeah, that's what they're talking about. Okay, good. Well, didn't we say that angle 4 equaled angle 1? So instead of angle 4 plus angle 2 plus angle 5, we're going to have angle 1 plus angle 2 plus, instead of angle 5, we already said that, through alternate interior angles, angle 5 is the same as angle 3, so we're going to substitute. And this is good old-fashioned substitution. All right, so there's the proof. All right, exploring interior angles. So polygons, we're basically using triangles, but polygons, like a quadrilateral, if you look at this picture, technically has two triangles. And that means you have how many degrees for that triangle? Well, we already know a triangle has, or should have, 180 degrees. Well, 200, or I'm sorry, two 180s is really just going to give you a total of, well, 360 degrees. Okay, quadrilateral, quad means four, and we have 1, 2, 3, 4 sides. All right, so I'll tell you what, I'm going to try to draw some more triangles here in this image. Looks like we have 3 triangles. So we got 180. Thank you, touchscreen, for doing that wonderful thing. 180 degrees plus another 180 degrees and one more 180 degrees. Should give us 3 times, let's see, that's 24, 540 degrees. Okay, now there is a quicker way to do this, and it's down here, polygon angle sum theorem. So we can draw triangles all day, but that starts to become a little bit more of a hassle. Instead, let's just count how many sides we have. 1, 2, 3, 4, 5, 6. Okay, so we have 6 sides. I'm going to use that formula. So n minus 2 times 180, and you end up substituting, so 6 sides minus 2 times 180. Sorry, that's a 180. And you're going to get 4 times 180. So let's see, we got 3,200, I'm sorry, 320 plus 400. So we should get 720. Okay. There we go. All right. So I'll tell you what, out of just pure curiosity, I want to go ahead and, you know what, I'll just go ahead and do one more. Let's see. Oh, Oh, that's okay. That one's a good one. Okay. So let's see. 4 times that. Good. All right. So I'll try this one more time for you guys. We have 1 side, 2 sides, 3 sides, 4 sides, 5 sides. Um, Again, we're talking about degrees. 6 sides, 7 sides. Okay, so we're going to substitute in 7 for n minus the 2. Okay, we're just using the polygon angle sum theorem once again, instead of drawing all those triangles and adding them all up. Okay, so we have 5 times the 180 degrees. So that is 400 plus 500, which is 900 degrees. Okay, and this one is going to be your turn. Okay, right here. So go ahead and try it. Try the formula and tell me how many degrees this guy is. All right, so examples of using interior angles. So in this situation, we notice that we have 9 sides to this polygon. So we can use the formula, okay, n minus 2 times 180 degrees, and we can substitute. Okay, you'll end up getting 7 times 180. Therefore, you know that all these interior angles should add up to 1260 degrees. And then they're just asking you to solve for the missing angle, okay? So basically all you have to do is, well, combine all the angles, all the degrees that you have already given to you. Um, Include the x, which we don't know. Okay, combine like terms, use the subtraction property, and eventually you're going to get x equals 158 degrees. Okay, so um, this is just algebra from there on. So the unknown angle is 158 degrees. Okay, so again, we had to combine like terms for these terms, okay, and then subtraction property, and you end up getting x equals 158 degrees. All right. So your turn number 2. Determine the measure of the fourth interior angle. If a quadrilateral means 4, so you can just draw any quadrilateral you want. That's a terrible quadrilateral. It should be a little bit more straight there. And basically you have one angle that's 89 degrees, another one that's 80 degrees. You have 104 degrees, and just asking you to find the missing angle. Okay. All right. So proving exterior angle theorem. Basically, you have an exterior angle is an angle formed by one side of a polygon and the extension of an adjacent side. So we're talking about here, okay? Here's our polygon, and in this situation, a triangle, okay, which is a polygon, has more than one side. And it's on the outside, basically created by an extension, and this is the extension that it was talking about, okay? So they say a remote interior angle is an interior angle that is not adjacent to the exterior angle. So basically, it's not next to, it's over here on the remote side of the exterior angle. Now, fun fact, the exterior angle theorem actually just says that basically this these two remote interior angles add up to the exterior angle. So basically, angle 1 plus angle 2 will equal angle 4. Okay? That's basically what the theorem is saying. So the measure of the exterior angle of a triangle is equal to the sum. Again, the sum is basically 1 plus those two angles adding up together, and it basically is that, okay? I think I said it differently. I think it meant to be like this, angle 4. Thank you, little touchscreen. I think during Christmas break, I'm going to figure out what that is, and I'm going to fix it. That's like on my to-do list. So angle 4 is going to be equaling to the two remote interior angles, or the sum of them. Okay, so that's what it's trying to say. All right, moving on. So here's an example. I know that here are my two remote interior angles. Here is my exterior angle. And according to the theorem, okay, for exterior angles, I know that angle A plus angle B has to give me angle, oops, touchscreen. I shouldn't even say oops because it's technically not even my fault. It's the software or something. All right, should equal angle ACD, and that's the exterior angle. All right, so angle A is 2Z. 2Z or not 2Z? That is not the question. All right, 2Z, and we have angle B, which is 5Z minus 2, equaling 145 degrees. Okay, notice I'm using the exterior angle theorem. Combine like terms. Okay, we're combining the Z's. All right, we haven't touched the -2 yet. Okay, let's go ahead and take care of it. Addition property. We'll get 147. And now we use the division property, good old algebra. So Z equals 21. Voila. Now they're asking for angle B, so that's something to realize. That means we have to substitute. So angle B was 5Z minus 2. So I'm just going to go ahead and substitute that in right here. So angle B equals 5z minus 2. And, well, z was 21, so we're going to substitute in. Thank you, little touchscreen. You are making my day so wonderful. There we go. Minus 2. There we go. All right, so 5 times 21 is 105. And 105 minus 2 is 103. So angle B equals 103 degrees. Yahtzee. All good. All right, next one. Your turn number 3. So determine the measure of the specific angle. So we have to find angle PRS. So let's see. Here we go. Angle PRS is this guy. Okay. Now they did give you this angle. Okay, what degree is that? And what do we know about the exterior angle theorem? All right, so set it up and solve for x. Once you get x, plug it back in because you're looking for angle PRS, the exterior angle. All right, same deal. All right, except in this situation, you want to determine what the angle N is. Okay, same deal, have to solve for x, use the theorem, and plug it back in. Okay, guys, take care, have a great day, and if you have any questions, let me know. I've actually done that once. It was pretty funny. It actually worked. It was really weird. All right, thanks, guys.